Hi, so in the previous video we talked about what are the three questions about chemical reactions that we're going to try and answer in this course, and additionally we actually gave the answers to those three questions. Now of course there's still more to do, but I wanted to start by just kind of giving a definition. I gave you kind of the words entropy, equilibrium, reaction rates, and those kinds of things, but I want to give you the words and kind of define those answers so that we have kind of a base to build off of as we go. So first up, we're going to talk about entropy. Entropy, as you'll recall, was the answer to the question of does our reaction start, right? And so entropy is what entropy measures is really is the potential energy of molecules in a system. So we should probably write that down. So entropy is the potential energy of molecules in a system. And so an example of this would be if we increase the temperature in a system, right? We're putting more energy into that system. That energy goes into the molecules, allows them to vibrate more, allows them to move around more, gives them higher potential energy. Right? In a reaction, that entropy, that energy that's in those molecules, is imbalanced against the energy it takes to make or break the bonds or move the electrons around or whatever we're doing in that reaction. Right? And so the more potential energy we have, right, the more likely it is that that energy can overcome the energy that it takes to start the reaction. When we combine these two ideas, the idea of entropy as well as the idea of the chemical energy that it takes for a reaction to occur, we get free energy, which is the term for that, right? And if there's enough entropy, that entropy is greater than the chemical energy needed for the reaction to start, then reaction begins, right? So if we know what the entropy of a system is, we can start to make determinations of whether the certain reactions will proceed. Will they start? Do we need to increase the temperature in order to put more potential energy into the molecules and allow them to begin that reaction? Right? The second one that I'm going to talk about is reaction rates. Now, reaction rates are pretty much exactly what they sound like, right? And reaction rate is the rate of the reaction, but that's a terrible definition. So let's talk about it a little bit more. In most chemical reactions, we think of them having two sides. We have the reactants, and then they produce the products, right? And so we can have more than one reactant, we can have more than one product, etc. It can get as complicated as you like. Um, the what reaction rates gets at is how quickly does the amount of product change, or how quickly does the amount of reactant change. So what reaction rates is measuring is how quickly the amounts change. So if you have a fast reaction with a high reaction rate, obviously the reactants are going to disappear very quickly, the products will appear very quickly, and so on and so forth, right? Equilibrium is the third one, right? And equilibrium, you'll recall, is the answer of, so reactant rates was how fast does the reaction go? Equilibrium tells us how far the reaction goes, right? How much product do we get out at the end of our reaction? And what equilibrium is kind of the end of the reaction. What equilibrium, in order to understand equilibrium, we have to know that chemical reactions don't just proceed in one direction, right? Not only do we have reactants reacting to make products, right, like we did in the reaction rates, but we also have the reverse reaction where products are actually reacting to go back to the reactants. And each one of these reactions has a rate, right? So the reactants are producing products at a certain rate, the products are producing reactants at a certain rate. And at some point, these rates are the same, right? The amount of reactants, how fast the reactants are producing products is equal to how fast the products are producing reactants. And of course, what happens then is you're not making any more of either one. For every reactant that reacts, there's a product that's reacting back the other way. And so what equilibrium is when the rates are equal, when those two rates are equal, right? The reactants to products and products to reactants. Okay? And when they're the same in both directions, that means that no more, so there's no more product formed, products formed. And also no more reactants formed, but usually that's not our main concern. Usually we're concerned about the products. So when we talk about how far does the reaction go, what that's saying is it goes until we get to a point where we can't produce any more product because the reaction rates no longer allow it. And so we're going to calculate all of these things throughout the course of the semester, but in its barest bones, what are we going to learn? This is it. Okay? So we're just going to make all of this more complicated for the next couple months, and then we'll call it a semester. Right, so we'll start on this in the next video, but we'll see you there.